Hi, this is a video for solving inequalities with variables on both sides, and I thought we'd open up this video with a geometry application. This type of problem you're going to definitely see next year when you're taking geometry, but I like to prepare you for the future, so we're going to go ahead and apply what we're learning in Algebra 1 for geometry. For this first slide, we like to find out what are the area formulas for the two different geometric shapes. And here we have a rectangle and we have a triangle. So what is the area for each shape? If you want to really test yourself and push yourself, pause the video, look online, or try to remember what the area formulas are for these two shapes. But we will come up with these two areas right now. So if we have a rectangle that has length and width as its sides, then the area of this rectangle is going to be length multiplied by the width. For the triangle, if this is going to be the height of the triangle, then the area is going to be 1/2 base, B is down here, multiplied by the height. So we're going to use these two formulas on our next slide. Okay, just a reminder, this is 3-5 out of your whole textbook if you'd like to take notes and view some extra examples out of your textbook. So now we're going to look back to this geometry application, and we're going to write and solve an inequality to find the values of x for which the area of the rectangle is greater than the area of the triangle. Well, first let's get down our area formulas. That's why we had to find them on the previous slide. So the area formula for this one, for the rectangle, was length multiplied by width. And then the area for this triangle was 1/2 base multiplied by height. And give me 1 second. I want to get rid of this section right here. There we go. Okay. Now, let's move this up some. I just want to have some more space so we can start working on it. So once again, we want to write and solve an inequality and find the value for x. So that's what we're going to have to solve for, isolate, for which the area of the rectangle is greater than the area of the triangle. So take a minute and think about what inequality is going to have to go there. If you did greater than, you're right. Now, if it said greater than or equal to, then we would have a bar underneath our inequality, but we're just doing greater than. So now we're going to look for the area of this rectangle. So the area is going to be 12 multiplied by x plus 2. And then we have our greater than sign because we want the area of the rectangle to be greater than the area of the triangle. And then we're going to use this information to plug in to find our area of our triangle. So the area is going to be 1/2. The base here is x plus 6, so 1/2 times x plus 16, and multiplied by the height, which is the 10, and multiplied by the height. Now let's go ahead and reduce the size of this slide, and I want to have some more work so we can start working on those two area formulas. Okay, so once again we have 12 multiplied by x plus 2 is greater than the area of the triangle, which is 1/2. And I'm going to go ahead and, let me take out the equal signs because that's why we have the inequality sign there. I'm going to go ahead and say 1/2 multiplied by 10. I'm going to move around those two numbers. We can do that because of the commutative property. And then x plus 16. I just want to go ahead and reduce the 1/2 and 10 first. So here I'll distribute. We all know that once we see parentheses, we distribute. So I get 12x plus 24 is going to be greater than 5 multiplied by x plus 16. And now I'm going to have to distribute again. And I get 12x plus 24 is greater than 5x. And we need to do 16 times 5. I don't know that off the top of my head, so we can do 5 times 6 is 30, and then 5 times 1 is 5, plus 8, so it's going to give us 80, plus 80. And now you have an inequality with variables on both sides that you can solve. Remember, I practiced with you just the other day that you need to get rid of you need to move over the variables first. So we'll finish this problem in class tomorrow, so make sure you're prepared and watched it. Okay, here's our first example, example A, and we're going to solve the inequality. Remember, we had some strategies where you have the variables on one side and the constants on the other side. But for this example, we want to get all the variables to the same side. And that's what I told you to always do first. So I'm going to go ahead and I want to get the 4y with the y on the other side. So I'm going to subtract 4y on both sides of the inequality. Y minus 4y is negative 3y, which is less than or equal to 18. And then I'm going to divide both sides by negative 3. Negative 3. Negative 3's cancel, or excuse me, they reduce to 1. And then we get y. And notice how I put here, don't forget to switch the inequality symbol because we're dividing by a negative number. So we get greater than or equal to negative 6. Go ahead and graph this on a number line. And I'd like you to write a statement of why did we move the variable over first. We discussed that in class just the other day, but we'll review it when I see you tomorrow for this lesson. Okay, here's our example B. We're also going to solve this inequality. Remember, the first step, always the most important thing when variables are on both sides, is to move the variables to the same side. So here we are going to actually subtract 2m instead of subtracting 4m because we want to keep it at a positive variable. So minus 2m to both sides, 2m. 4m minus 2m is 2m minus 3 is less than 6. And now it's a basic two-step inequality. This is why we always want to move the variables first. We're going to add 3 to both sides. This reduces to 0 and we get 2m is less than 9. And then divide both sides by 2. So m is going to be less than 9 halves. Go ahead and graph that on a number line. Remember, 9 halves is the same thing as 4.5. Okay, so in this lesson, we looked at a geometry application in the beginning. I went through 2 examples for you, example A and example B, on how to solve an inequality with variables on both sides. And now I'm going to talk about some special inequalities that you can encounter. And this is with variables on both sides, but it shows you what happens if you can get all real numbers as your solution or no solution. So let's go ahead and read what I have here in white. Some inequalities are true no matter what value is substituted for the variable. So no matter what x values I plug in, I'm still going to get a true inequality. For these inequalities, the solution set is all real numbers. Since all real numbers are solution, that is our solution for the problem. So I went ahead and used color coding of black and white for this inequality you see in front of you. And we're actually going to go ahead and scratch out the white. Right? I'm going to take out the 2x and the 2x here. And notice how it's the same variable. Now we're just going to look at this statement in the middle. So you have to ask yourself, is negative 7 less than or equal to 5? Well, if you get stuck, you can always draw a number line. And we could have 0 over here, negative 7, positive 5. And notice how negative 7 is less than 5 since it's more towards the left, which way is more less. So this is a true statement, therefore it is all reals. And this only happens when you have the same variable with the same leading coefficient on both sides. See, notice how we had the 2x on both sides. Now on the next slide, we'll look at an inequality with no solution. For our last slide, we're looking at an inequality that has no solution. So let's go ahead and read the words in white. Some inequalities are false no matter what value is substituted for the variable. So no, I can't think of any x value that I can substitute in in this case, y, that I can substitute in and get a true inequality. It's always going to be false no matter what I do. So these inequalities have no solution. Their solution set is the empty set, which we also can label as 0 with a slash mark through it. So once again, we have 6y and 6y, the same variable with the same coefficient on either side of the inequality. I'm going to go ahead and scratch out the 6y's, and we're just going to look at the numbers. So 6y goes away. And now you have negative 8 is greater than or equal to 21. Well, if you can't understand if it is greater than 21, we're going to look at a number line. And here we would have 0, negative 8, and then positive 21 would be over here. And notice how negative 8 is not greater than 21. It's more to the left, which is more or less. Therefore, this statement is false, and it will always be false. So our solution is no solution. Go ahead and end the video now. Write your questions, write your summary, and list any questions that you have. If you had some difficulty with the geometry application, you need to write down questions for that slide and ask me those questions in class.